In an earlier video, I had mentioned that there is no multiplication of vectors, where you multiply two vectors together and get a third vector. And that is true, but there is something called the dot product of a vector. And that's what we're going to talk about in this video. Okay, so if you're given two vectors, then you can do something called the dot product. And here it looks like you're multiplying two vectors together, because you're using the multiplication symbol. But the way you find the dot product is you multiply the first components and then you multiply the second components and you add those two numbers together, and what you get is a scalar. So the reason this isn't a multiplication of vectors is because multiplication of vectors would be multiplying two vectors together to get a third vector. But this is, in a sense, kind of multiplying two vectors together to get a scalar, and that's just a different sort of operation altogether. And it is a meaningful operation, and it actually plays an important role in many, many things in math. And we're going to look at just one application in this video here. So let me actually find the dot product then of this one here. So v dot u, so this would be 5, 3 dot negative 2, 4. And so I'm going to take 5 times negative 2. Well, I'll just write it out. 5 times negative 2 plus 3 times 4. And so this would be negative 10 plus 12, and that would give you 2. So the dot product of this of these two vectors would be equal to 2 here. Okay, so that is the idea of the dot product. It's very easy to do. Now the interesting thing is it has a very interesting geometric interpretation, and I'm not going to go into all of that, but what I do want to show you is that another way, this is kind of the way to compute it when given the component forms, but another way to define the dot product of two vectors here is to take the magnitude of the two vectors times the cosine of the theta between the vectors, where theta is the angle between the vectors. Okay, so this here is actually the same as this here. And so that's really kind of amazing. It's pretty interesting. You can actually prove that. And one way to think about this is if you multiply u and cosine, if you remember, this is actually the horizontal component of u. And so what you're actually doing is you're taking the horizontal component of u and multiplying it by v. Or if I took and commuted these around, which I could do, I could take the horizontal component of v and multiply it by the magnitude of u. And that's actually kind of the geometric interpretation. So it's the horizontal component of one of the vectors times the magnitude of the other vector. And as it turns out, it doesn't matter which way you do that. Okay? And so the interesting application of this then is that this is the angle between the vectors. So when you're given these in component form, I don't know the angle between those two vectors, but this actually provides a way of finding the angle between the two vectors. Okay, so let me show you how that works. So what I need is the magnitude of u and v. So, and I'm going to do a graph here just to see if our answer makes sense in a minute. So let me find the magnitude of u and v, or v and u. So the magnitude of v would be, this would be 25 plus 9, which would be 34, Okay, and then the magnitude of u is going to equal where is u? Okay, this would be 4 plus 16, so that'd be the square root of 20. Okay, so what this means is that v times u is going to actually be equal to the product of the two magnitudes, so that'd be 34 times square root of 34 times the square root of 20 times the cosine of theta. And see, what I want is the angle between the two vectors. So what I have to do is solve for this theta. So I know this here is equal to 2 because I can find the dot product of that. So I get that 2 is equal to, square root of 34 times square root of 20 times the cosine of theta. So basically here I would get cosine of theta is equal to 2 over square root of 34 times the square root of 20, and then I can find my theta. So by doing the inverse cosine of this. So maybe what I'll do is I'll take 2 divided by, and then in parentheses here, I'll do square root of 34 times the square root of 20. And I'll get all of that. So that's everything over here. And now I'm going to take the inverse cosine of that. So second cosine of the answer. And I get 85.6 degrees. And this would be the angle between the two vectors. So let's actually graph the two vectors and see if that makes sense. So I'm going to do 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so V here would be 5, 3, which would be right here. So that's V. And then U is negative 2, 4. And so that would be this right up here. And that's U. And so it's saying that this angle here is 85.6 degrees. And that is definitely believable. That definitely makes sense. Okay, now the way the book gives this, if you look at this, this is the dot product, this is the magnitude. So the book actually gives you this formula, that the cosine of theta is equal to V dot U over the magnitude of V times the magnitude of U. And so the book actually gives you this formula, which is actually taking this definition and dividing this by that. And so you could you can find the dot product, find the magnitude, set this all up, and then take the inverse cosine, and you'll get the angle. And of course you're going to get an angle between 0 and 180. Cosine gives you the angle between 0 and 180. And so you're going to be getting the smaller of the two angles between. So I'm not going to be getting this angle, I'll be getting that angle. So wonderful application, a really, really neat tool. And it's only the beginning. The dot product has all kinds of amazing applications. And the neat thing is when it's in component form, this is so easy to get. It's just amazing that it works out that way. It's so cool. So maybe to end here, I got a couple vectors. Why don't you go ahead and find the dot product of these two vectors and then find the angle between them. So go ahead, pause the video, see if you can do that, and then start the video back up and see how you did. Okay, so let's see how you did here. So I'm going to first do the dot product between these two. And so this would be 3, negative 5, dot, negative 5, 1, and so I'm going to take 3 times negative 5 plus negative 5 times 1. So this is negative 15 plus negative 5, so this is negative 20. Okay, so that's my dot product. So now let's find the magnitudes of these. So the magnitude of V is going to be square root of 3 squared plus negative 5 squared. So 9 plus 25, which is square root of 34. Was that the same one that I had on the front? Oh, 5, 3. Okay. So now U here, the dot product here is negative 5 squared plus 1 squared. And so this is square root of 25 plus 1, which is square root of 26. Okay, so now I can just set up that this cosine theta is equal to the dot product, which is negative 20, over the product of the two magnitudes, negative 34, negative 26. And now I can calculate I'll calculate this here. So negative 20 divided by, in parentheses, negative 34 times square root of negative 26. And I get this, and now I'm going to do inverse cosine here. So shift cosine the answer, and I get this angle. I get that theta is approximately 132.3 degrees. Okay, so let's go ahead and we can graph these and see if that is reasonable. So I'll do 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So 3, negative 5 would be here. And so that is V. And then U would be negative 5, 1, which would be like way up here. It would be here. And then this would be this angle there, 132.3 degrees. And that is, again, is believable. Okay, so really cool stuff. This is really neat stuff. You know what? That might have been cut off while I was doing. I can't remember. Really, really neat stuff. Another neat application is that if the dot product, I'll write this down. If the dot product equals 0, then the vectors are perpendicular. The angle between them is going to be 90 degrees. And this is very easy to see, because if you have the cosine of theta is equal to, V times U over V times U. And if the dot product is 0, this would be 0 over V times U. And the magnitudes here don't matter, you just get 0. So when is the cosine theta equal to 0? When theta is equal to 90 degrees. And so oftentimes the dot product is used to see if two vectors are orthogonal to one another. The term orthogonal means right angles with one another, or perpendicular to one another. Kind of like the orthodontist straightens your teeth. Orthogonal vectors are straight, right angled vectors. So, okay, really cool stuff. I really like this stuff here. So vector spaces and this dot product and this other stuff. This is one of the things I really remember from my linear algebra class in college, and at the time that was kind of one of the subjects I really enjoyed and stuff. So I really like this stuff. So okay, I like the abstract stuff better than the applications to physics and stuff like that, because I'm not a science person, but I've thought a lot about these abstract relationships between things and their connections, and I really like that stuff. So okay, very good. That's the dot product then. I hope you enjoy that. And that's all we're going to do with the dot product, is learn what it is, introduce you to the idea, and then this application of finding the angle and also knowing if two angles are perpendicular. So, hope you enjoy that.